next step is by replacing k. We have studied that by replacing k, this index starts from 0 to infinity, but this is n and this is k. As you know that this index variable is also called as dummy variable. Dummy means you can dx can be replaced by any variable, can be replaced by t or s or any other in the integrand along with the dx or dr with n, which means n starts from 0 to infinity. Cn plus 1 into n plus 1 x to the power n equal plus 2 into n 0 to infinity Cn x to the power n equals to 0. Now you can take common as this sigma, and that sigma starts from n0 to infinity. And also one more thing you can take common, and that is x to the power n. So by taking x to the power n, the remaining terms are Cn into n plus 1 and plus 2 into Cn equals to 0. As you know that x to the power n can never be equal to 0. If n is any kind of integer, any kind of rational or irrational number, it can never be equal to 0. So that means this relation Cn plus 1 into n plus 1 plus 2 Cn is equal to 0. Now that generates the recursive formula, and recursive formula is, if you have the previous 2Cn to other side, it becomes minus 2Cn, and if I divide it by n plus 1, then it becomes this. So that is the recursive formula of the given differential equation. Now what is the importance of this recursive formula? The basic theme is that this formula generates each and every term. If you have the starting term, then you can proceed further. So if for n equals to 0, by taking n equals to 0, that develops the first or second term, minus 2c naught divided by 0 plus 1, that is equal to minus 2c naught. And for the next term, we are into, for n equals to 1, Cn plus 1, that becomes C2 minus 2C1 divided by 1 plus 1. That makes it minus 2 divided by 2, and C1 means minus third term, I guess. For n equals to 2, C3 is minus 2C2 divided by 2 plus 1, minus 2 by 3 C2, and instead of C2 you can write it plus 2C0, each and every successive terms. And also for n equals to 3, C4 equals to minus 2 C3 divided by 3 plus 1 is 4. So minus 2 by 4, and C3 is minus 2 into, that is minus 4 by 3 C0. So I am writing instead of this as minus 4 by 3 C0. So that is equal to, so first term is C0 and starts from 0 to infinity Cn x to the power n. So first term is C0. Second term is C1 into x plus C2 into x square plus C3 into x cube plus C4 into x to the power 4 to so on. C0 plus C1 is minus 2C0, and C2 is plus 2C0 into x square, and C, I want to generalize it in one series. Okay, and C4 along with the x cube, and C4 is this. minus 2 by 4 minus 2 by 3 to C naught into x to the power 4 to so on. So you can generalize it, and it can be seen if I take it as common. C naught, because first term doesn't have 2. So if I take this common, then it means that 1 minus 2 into x plus minus 2c into minus 2 by 2. Yes, you can also write it. Can be written as, if I take it common, then it can be written, this term if multiplied can be written as 2 into x whole square divided by 2 minus 2 into 2. That means if I replace this as this whole term, it will be good for me. So minus 2 by 3 into minus 2 by 2 into minus 2 C naught. If I take it like this, then it becomes 2 cube. You know, that is 2 cube, 8, and minus 8 divided by 6. Yes, x cube. Alright, and next step is minus 2 by 4, and in the bracket you can write it as minus 2 by 3 into minus 2 by 2 into minus 2 C naught, and close the brackets as required. Then you can see that 1 2 3 4, so there are 4 2 and positive sign. So 2 to the power 4 x to the power 4 divided by 4 into 3 is 12, 12 into 2 is 24. So this is a pattern that you can see is I am writing in the next step, and that is C naught 1 minus 2x plus 2x whole square by 2 factorial, that is 1 factorial, and minus 2x whole cube by 6 means 3 factorial, plus 2x to the power 4 by 4 factorial to so on. And if I take the generalized term, that will be 2 into x to the power n divided by n factorial. So that right, e to the power x has the series 1 plus x square by 2 factorial plus x cube by 3 factorial to so on x n by n factorial. So if you compare this series with this, then if I replace this with an alternating minus sign, if I replace this with 1 and along with the odd terms, it is minus 1 to the power n. So it will be the series of e to the power minus x. And one more thing, if I replace instead of x, I will replace it as 2x, then it will become minus 2x, and that will be this series. So your answer will be C naught e to the power 2x. That is the answer. So by power series, your differential equation has this solution, C naught is a constant, and for the analytical solution you have seen that y is equal to C1 e to the power minus 2x. C1 and C2 are constant, so that these are constant, so that means that your answers are identical. So this is all about the power series, and this series is also a convergent series, right? So basic three series are e to the power x, that is 1 plus x plus x square by 2 factorial plus x cube by 3 factorial to so on x to the power n divided by n factorial. And if you replace it by minus x, then with the odd terms it remains minus, and with the even terms it remains positive, so that becomes alternating series. Second one is cos of x series. Remember that from these terms, if you take all the even terms common, like first and third and all these terms, that will be the alternating. So with the alternating signs, that will be the series of this cos of x. So 1 minus x square by 2 factorial alternating signs, x4 by 4 factorial minus x 6 by 6 factorial to so on. This is the general series of cos of x. And from this e to the power x, if you have the alternating signs along with the odd terms, so with the odd terms it rises to the sin x series, and that will be this term and all those terms, minus x divided by 3 factorial plus x5 by 5 factorial minus x7 by 7 factorial to so on. So these are 3 general series of the power series.